So let me elaborate or let me apply the entropy principle that we discussed in the previous video to certain cases. What we have said, the principle of increase of entropy or entropy principle says that in the system, let's say this is a system which is isolated. So I am showing these lines, hatching kind of lines to show that the system is isolated from the surrounding. No heat and mass interaction takes place across the system boundary, and if this system undergoes a process, then the change in entropy will be greater than 0. That means it will be positive if that process is irreversible. It will be 0. That means there won't be any change in entropy, right? Any change in entropy if the process is reversible. Okay. Now you also can reflect. This is system, this is surrounding. In the system, if the process takes place which is irreversible, the entropy of the system will increase. Entropy of the surrounding is unaffected because this is isolated, right? So what it means is that this system, there is increase in entropy of the system because system has undergone irreversible process. Surrounding is unaffected, but system plus surrounding is universe. So what has happened to the entropy of the universe? Entropy of the universe has gone up, right? There is increase in entropy of the universe. Remember this. You can understand this. System and surrounding. Entropy of the system increases. Entropy of the system increases. Why? Because we have just proved it is undergoing an irreversible process. Surrounding is unaffected because there is no heat interaction, right? There is no work interaction. The system is isolated. System plus surrounding is universe. So if delta S of the system plus delta S of the surrounding, right? If you look at this, because delta S of the system is greater than 0, this will be 0. So this is positive, this is 0. So this together will be greater than 0. Okay. So principle, every time a system undergoes a irreversible process, there is increase in entropy of the universe. I will talk more about that later, but basically this is called as so basically second law of thermodynamics is telling you that entropy of the universe keeps on increasing because in nature all the processes are irreversible, right? So entropy of the universe keeps on increasing. But let's come to universe later, and I am going to talk more about that. But let's consider, if you have understood this, let us consider a case that would make this concept very clear to you. Let us say that we have two bodies. Body 1 is at 1000 Kelvin, body 2 is at 200 Kelvin. Imagine that these temperatures are constant. Imagine them to be source and sink, right? That means no matter how much heat flows from this, its temperature will not drop. No matter how much heat it receives, its temperature is not going to increase. Okay. A practical case, you can consider this as, for example, some vapor which is condensing. Okay. When vapor condenses, it gives out heat, but its temperature is constant because its phase is transformed. This could be considered as some liquid which is converted into vapor. Okay, vaporization process. Again, then it's at constant pressure, and if you consider that, the temperature can be considered as constant, although you are adding heat to it. Or in general, consider this as source and sink, and we have already defined source and sink. Let's say I consider them part of a system, and we consider that there is no heat interaction with the surrounding. The system and surrounding are completely isolated. There is no heat or work interaction across the system boundary. This together is our system. These two bodies are our system. Now let's say that we allow heat transfer. And initially we had some separation wall, there was some insulation, but now we have removed, and let's say we allow heat transfer. During certain time, let's say obviously heat will transfer from here to here, and let's say that during certain time the amount of heat transfer is say 50 kilojoules, right? 50 kilojoules. Now if 50 kilojoules of heat is transferred, let's say this is body A, this is body B. What will happen to entropy of the system? What will happen to the entropy of the system? Now you can immediately say that because we know that ds is greater than or equal to 0, this process is irreversible process. Why? Because the heat transfer is occurring across finite temperature difference. It's not infinitesimal temperature difference, right? If it were occurring across infinitesimal temperature difference, that heat transfer process would have been reversible. But this is finite temperature difference, so this heat transfer process is irreversible. Remember, this is an irreversible heat transfer. So if it is irreversible, entropy of this system will increase, right? Because this is what principle of increase of entropy tells you. So just think about it. Let's say this is A, so I am writing delta SA, right? And let's say entropy of this. So we will say that what is the entropy change of the this system? It will be delta SA plus delta SB. Entropy change of body A, entropy change of body B. Algebraically, if you add, that will be entropy change of the system, and it should be positive because that's the principle of increase of entropy, because this has undergoing an irreversible process. Now see what is delta. So you know that when heat is transferred, the change in entropy ds is, you say, dq by t, right? And if you want to find out delta s, you integrate dq by t. Now when you integrate, if this t is constant, you can take it out. So essentially integration of dq is q. So entropy change for these bodies is heat transferred upon the temperature. So here you can see heat is given out. So this is minus. So it is minus 50 q by t, right? It is q by t. T is 1000. Minus 50 by 1000 because temperature is constant. This body is receiving the heat. How much heat is being received? 50 kilojoules, right? So it is positive. Heat received is, that means it's positive. So it is plus 50. What is the temperature? 200, right? Temperature 200. So if you, yeah, that's right. So if you see this, q by t, q we have taken as 50, and if you see this, do the algebraic sum, right? You can immediately see that this is denominator is higher, here denominator is this is smaller, and the numerator is same. So this obviously is greater than 0. You can do the calculation, right? This is greater than 0. That means what has happened? The entropy of the system has increased because the system has undergone an irreversible process, right? So this system, there is irreversible process has occurred. As a result, entropy of the system has increased. What about the entropy of the surrounding? It is unaffected because system is isolated from the surrounding. So entropy of the universe has increased. Entropy of the universe has increased. Every irreversible process increases the entropy of the system if the system is isolated. That's important. Here we are considering isolated system. So entropy of that system has increased, and as a result the entropy of the universe has increased. Thank you.